Well, hi, good morning, and thanks so much for joining me here in my shop. Today is March 8th, 2020, and a somewhat of a disappointing result here with this radio. When I changed the filter capacitors, I kind of thought that might knock out the hum, although the hum has been not really sounding like a power supply hum. And I think I discovered what's going on with this radio while I was working on the video here. I just looked over at the radio and oh, it set the phono. Perhaps in my earlier videos you as a viewer may have noticed this. You might have been yelling at my screen. Well, so some kind of message got through anyway, so we're going to try this radio again and see what it does, only this time I'm going to flip it to radio. Yeah, that's a good idea. Okay, I'm going to turn the switch on. Power's not on yet. Speaker still connected. Everything ready to go. Of course, I'll still be relying on the dim bulbs here. Here we go. Okay, again, I don't know if it was visible on the camera, but the bulb did just glow a little bit perfectly. Quick trim, man the volume. We don't know what's going to happen here. Volume is nothing. Turn it up a bit. Oh, that sounds more like a radio this time. Okay, let's give it a go. Now the antenna is not connected properly. Oh, it's rolling on its capacitor here. I'm going to lay the radio down properly. I think I can do it safely here. I think there's too much hanging out anywhere. What did I say? I could do that safely. I just finished off this radio. Okay, what happened there? What happened there? Well, one thing is the speaker became disconnected. That's one thing that happened. Why did it why did it sound like that? Oh my gosh, what could have happened? This can't move that much. What could have happened there? Okay, so switch is on. Let's put the power back on. Again, just using the dim bulbs. Okay, so it likes being up like this for some reason. I'm just gonna stand it up here. There we go. I'll hang on to it. It's not the wisest thing to hang on to a radio like this, you know. This is not a wise move. Not a wise setup. Okay, hold it, power off. Just not wise. Not wise, because something small can happen, and next thing you know, I'll throw this radio onto my shop floor. I don't want that to happen. Even, you know, even something falling somewhere in my shop and making loud sounds enough to make me throw this guy a mile. Now I don't know what happened to it when I tipped it down last time. Hopefully it's not going to be crazy. Here we go. Okay, good. So I think a dirty volume control is causing the hum we're hearing. See, there's no hum right now. Now the hum comes in. I think that's the volume control slider losing contact. Let's fix that. Let's fix that. That's easy to fix. I have some magic elixir here. Yes, it's WD-40. Okay, aficionados will be upset with me when I do this, but let's just see here. We can get at this. Gravity's in our favor this way. Right down into the volume control. A little cleaning action. Okay, volume down. Let's try it again now. Let's see if that just took the hum out. So if the slider detaches itself from the surface it's sliding over, if there's a dirt film and it rides up on top of the dirt film or oil or whatever it might be, that then no longer is that's not a particularly low impedance circuit to begin with, but its impedance goes way up because it's basically an open wire. Open wire, another word for that is an antenna. So you have an antenna in the middle of your radio hooked up to the audio circuits, and what do you think that antenna is going to pick up? In this case, it's picking up hums. That's my belief. Let's see if I'm full of crap here. Volume's down. So if that's true, and I cleaned this successfully, then there won't be any more of that hum. We'll just hear the volume go up and down. That's a very gooey feeling volume control here. Well, it didn't get rid of the hum, but it got rid of the funny business in the volume control. Okay, with no good antenna, obviously signals are getting through the radio now. Can we possibly pick anything up? The antenna isn't even hooked up right. What is that? I have some plates shorting in the capacitor. Now when I fooled around with the capacitor's pivot point at the back here, and I released it a bit, that can cause the rotating plates to shift towards the back of the radio, or I guess it would be towards the back. When you tighten it back up, and you don't tighten it up quite right, those plates can lose their centering in the stator plates. And maybe I've done that. Because, you know, the tolerances in a capacitor are amazingly low. Something is something loose under that tube socket. What happened there? I take my finger off that when I'm doing that. Remember these metal outside of these metal tubes is grounded in a special way inside this radio. I think whatever it is, I'm just disturbing the thing over here. Oh, this is really quite bad. Let's take a look at that. Watch it now. This is a shock hazard radio. Let's go under there and see what we can see. Is that tube all the way in? Yeah, that tube is not all the way into the radio. Okay, I'm just going to turn the radio off for a moment while I push it down in. Now let's turn it back on. Oh no, didn't like that at all, did it? Something going on under there. Power's off. Plugs out. WD-40 out of the way. This tube. So we'll flip it up. Get these off here. This way. What is going on? We're down in this area. I've done nothing down there. So I'm going to wiggle the tube a bit and just look at stuff. So the tube is moving as if it's loose, as if Hear it? Now what is that? Is that the tube? Maybe that's the tube. The tube itself may be in trouble. I'm not sure how possible that is. Come on around. Sooner or later that other antenna wire is going to break. So oh, how do you like that? This tube's in trouble, I think. Let me take this tube out. There's something wrong with the tube. Something I've never noticed in a tube before. So there's a metal plate here on the bottom. This is metal. There's a plastic plate here on the bottom. And the pins are coming through it, and then that plate is attached somehow to this skirt, this metal skirt, which I believe is the same piece of metal as this. It may not be. There may actually be maybe a seam right in here. It's maybe a different piece of metal. If I wiggle this, it's separating right in here. And that I think is causing the noise, because I think this, maybe this is a collar I can actually slide up over the tube. Is that how this is? Yeah, tubes aren't supposed to be like this. Little metal tabs here. So this collar is just fixed by little metal tabs. And they are not bent in very much on this tube. Have I got another one of these tubes handy? Yeah, right here. So I've never really looked at how these are constructed. So this one, the metal tabs are bent in a little harder, a little further. But that's not very much. So it's the same deal. This collar, it's got the number stamped right into it, into the collar. But the collar's not integral to the can. That's the question. Is the collar integral to the can? And what am I going to do about this? I have to stick another tube in there, or just squeeze these, squeeze down these tabs better. That's probably the first thing to try. Save the tube. I think it's all one piece of metal through here. Where's my close-up camera? A lot of this has been out of focus, maybe. I'm sorry, I'm not looking at the camera image. I apologize if that's what you've been seeing, is a lot of out of focus stuff. Let's try the close-up camera here, and I think we'll have better luck examining this with that. There's definitely a line of rust right in there. Oh, that looks like a separate piece. So this is one metal piece, and this is a collar going around it. There you can see the made in Canada. This is a Rogers tube, I think. No, Westinghouse. Rogers, you know, the guy who owned this meter. He made a lot of vacuum tubes too. Where's the camera? Here it is. So what I do, just push these tabs in harder. This is tube. So the tube is very sensitive to any kind of vibration. Yeah, it can just be variations in the position of this collar at, you know, minuscule variations or slight changes in the contact of this collar. If you can just get it stable, I won't hear any of that anymore. So I don't know what you do. He's trying to do this. Did I do anything there? It's very strange looking. It's like it's broken off. It's missing. I think that one's missing. Am I not seeing this right? Let me look with my own eyeballs here. Yeah, these are hardly dented in. can't imagine somebody took this apart once. Well, why would anybody do that? So maybe the way you gotta come across like this. Kind of tell what I'm doing. Oh yeah. When you're doing work like this, you might find it a little odd, but it's not odd. I cannot look at the computer screen. I'm looking at my hands. And so you've got a better view of things than I've got. I can't look up at the screen. I have to watch my hands, just like anybody. I don't think I'm having much effect here at all. I don't feel anything springing or moving. Still, you can hear it. Just like there isn't any actual bend over tabs here. What they've done is you just take the collar and with a punch smash it in there a little bit. You can see the scratches from my pliers on it. You can imagine this going into some kind of jig. Making these things by the hundreds like this. One day somebody comes along and goes, hey, the punch isn't quite going in far enough. We've had some rejects. So they readjust the punch. So if the punch is better, then the tubes are solid. But in the meantime, 40 came out like this. 40 slipped by their process. And in the end, this little tiny problem causes weird noises in the radio. So there's lots of interesting videos on YouTube. You'll watch old manufacturing operations making stuff like this. And one of them I watched right at the end of the process after building a tube like this. They're coming off the end of the line at quite a rate. There's an awful lot of stages and steps, and lots of things can go wrong in the process of building this. So the last thing they do is they test these. They put them in a carousel, a large carousel, the size of a card table sort of thing. You have like maybe 20 of these tubes plugged in all around the perimeter of this circular jig, I guess you would say. And the whole jig, tubes and all, like a great big turntable, snaps one turn, maybe, I don't know, 10 degrees or something, ka-chunk. And this brings the tubes into a new position in the test jig, and a new test is applied. And there's like 20 tests that are done around this jig. And you could see it as it's going around, and the new tubes are going in at the start and the old tubes are being pulled out. And what's happening in this thing automatically is if the tube fails the test, a pusher knocks the tube out of this carousel and down into a bucket. And so at the end of the day, or whenever they want, they look in the bucket and they can see we got 5 of these, we got 1 of those. They've got 14 failing the so-and-so test, whatever that might be. We better go up the line and talk to the guy supervising the so-and-so stage so we can correct this problem, because we got too many tubes in our failure bucket here. That's how this was done. I couldn't believe it. That was the end of the road for a tube. And they were being kicked out of that carousel too. They were coming out of that carousel. I'll bet you at least 1 in 10 was being kicked out. It's a really big deal making these things. There's a lot of precision inside them. There's many steps to it. Difficulties because of vacuum and all kinds of stuff. So, and in the end it comes down to they didn't squeeze this piece of metal band quite enough. What if I whack it with a hammer? That's probably not a good idea. The only thing I can do is just put my pliers on it really carefully and try to pinch it down. Like I've done, but I'll do it a little more carefully here. Let's do it like this. Just try to catch more of the edge of the metal. To some degree, my role, and any of you who are doing this work, your role is to make things last. It's not to find ways to throw stuff in the garbage. That's what I think. I don't think this is going to work worth a hoot. I don't think I can get any squeeze power on it. Watch your fingers. My pliers are going to snap closed here. It's better. It's getting better. Try it again. They just want it stable enough that it doesn't, you know, when you whack the radio, it doesn't do what it's doing right now. Whack the radio. Don't whack your radios. Actually, I'm pretty good at radio whacking. I got special whacking sticks. Whack away. I got an email from somebody the other day saying they followed my whacking techniques and whacked their way into finding something wrong with their radio that they couldn't find otherwise. So, caveman radio repair. Just need a stick and 2 rocks, and you're there. I don't think I'm going to get any further on this. Oh, Mr. Peanut is out there. Hey, that's pretty solid. Okay, don't knock it loose, Jim. Put it back in. Yes, Peanut, I'm coming, buddy. Just hang on. Here we go. The daily routine here. Come on in. Peanut, push the door. Come on, push it. No response. Come on in. Come on, this is every day. It's the same thing with you. Come on. Come on. Come on. It's the daily standoff. And he's won again. He's won again. So I'm going to stop for a little while and come back and mess around with this radio some more in a bit. We'll see if I got rid of that the loose sound there. Okay, Peanut, I'm coming. I'm coming. Okay, so I think I want to focus on the audio side. It's my usual sort of first foray into the electronics inside the radio here. And it has a phono input, which I'm now well aware of. So I think what I'm going to try doing is feeding a signal into the phono input. We'll hear what comes out of the speaker, and then I can start working on the audio side of the amplifier, and if there's changes or improvements or it starts working, we'll know because of the way I'm doing this. So let's just take a look here. So I'm going to use this audio generator here. Output's a little wild for this purpose, but I think it'll be okay. Plug it in. Oh, I got a very short, sort of a standard phono plug. No, there was no switch under here, was there? There's a switch on the back. Right, okay, just getting conscious here. Switch it to phono and plug it in. I'm on the red one. Okay. You can anticipate people trying this with their Walkmans. Walkmans. Where did that come from? Walkmans. I had a Walkman. Okay. So this is already on. I don't know if it's sometimes, like all this old equipment, sometimes it doesn't produce an output because of problems with the buttons and switches, so I'll have to sort that out. Well, let's give it a go and see. Maybe it's coming right out of the speaker now. There we go. Not plugged in. You know, a slow start. If you're trying to make the electricity jump from the outlet to the plug, it's going to take a while. Let's try that. So right now we're on B. We're pretty low. Let's put it up 1,000, about 1,000 hertz. I hear it. It's still warming up here. That's full volume, but that's a very low signal coming out of there at the moment. Great. Let me turn the radio down. Well, the volume's having minimal effect. I don't know what that tells me. Let's hit it with a little more signal here. Okay. So, audio's working. Now we can kind of get a feel for the volume. Okay, and let's just flip the tone around here. This is Oh, I was going to say it's a good test of the speaker, but actually it's a test of my speaker. It's not a test of the speaker in the radio. And we'll go up. Get a little loud in there. And we're testing the audio circuits in the radio, but we're also testing the speaker. So I certainly hear that. Oh yeah, right up. So nothing wrong with the audio range, and actually the audio amplification in this amplifier is good. And I didn't hear any funny hum or buzz or anything at all. Let me unplug the input here. So that's what it is. It's an open circuited input to the amplifier without some kind of resistance plugged into it, like this. There's an output impedance to my generator here. It becomes an open wire. It becomes an antenna, and then any little signal can have its way with it, and then it's straight into the amplifier, and we get to hear it. So that's what that is. And that's probably what was there right from the start, because I wasn't smart enough to flip that switch. No antenna. If you notice, I finally gave up on the antenna. I just cut it free because I got tired of it flopping around doing nothing anyway. So I think we'll continue focused on the audio circuits anyway, and even though they seem to be working fairly well, once again, very surprising, a radio full of tired old capacitors can kind of work. So the audio circuits are going to be all around the output tube, which is up here. So, this looks like a replacement. This is obviously a replacement. And the rest of these, especially this totally the worst looking capacitor I've ever seen, is in here. Probably just doing all these. This capacitor here is probably, this one here, probably the one conveying the audio from the radio up into the amplifier. Not sure of that. Can't be sure of that without poking around a bit. Okay, so that'll be my my work for this afternoon. And we'll just go ahead, and I'm just going to replace those guys. You know what I'll do? I just kind of draw. Where's the volume control? Up here. Yeah, maybe I'll just kind of like draw a line across here and say everybody above can be replaced. Assume this guy might be audio. I don't think so. And all those guys are probably just radio capacitors. Okay. Great. I'll work away at that. Okay, now that I've detached the antenna, I can flip the chassis right over and have it sit like this. Much better to work on. And the first capacitor I'm going to go after is this one. So this guy is going to the center post on the volume control. So this is the sound heading from the radio, or the phono for that matter, on its way to the amplifier in the detector tube. That's his job. Small, fairly small capacitor, 0.005, and I'm wondering about how I'm going to get it onto this post here, which is just a little bit blocked. I should be able to do it. Okay, so I'll stick in that capacitor where the one is that you see. Thought I had that kind of hooked on there good, but apparently not. Let's try again. See if it'll fall off. It's pretty common to kind of temporarily squeeze your component wires down onto a terminal, but then as soon as you melt the solder, it all just falls off. That's not quite what happened for me though. And it did not fall off this time. Okay, that's good. Oh, I did that a little too soon. The solder was still wet. Okay, come around here. I want to come in there. before I make a mistake, I'm going to make sure that's the right terminal I'm hooking that capacitor up to, because I cut the old one away, and you know what, I could easily make a mistake at this point. So I'm just going to quickly check the schematic here. Okay, it's pin number 2 it's supposed to go on to, and that's the one I was headed for. Pin number 2. So I was not on my way to making a mistake. So if this capacitor is leaky, you can get some DC flowing through your volume control, through the slider, and to make the volume control noisy, you can't get rid of the noise. That's the effect it has. There we go. I put it up against the back apron, just like the original was done, up against it. Good, that's good. Okay, next one would be, well, now there's one that's bringing the signal to the volume control. It's even lower down there, right down there, and it's buried under this, this, and this. So I'm not going to make that the next one. Should probably start dealing with these. So this is certainly a replacement here. I'm going to take this guy out first. I'm just going to work my way down. We'll deal with that guy too. Or what I could do, you know what I could do? Here's what I'm going to do. I'm going to cut this just one side, get it out of the way. Same thing with this guy. Right in the middle of his wire here, so I know where it came from. Okay, I swing them out of the way. And there. Now I am going to go after that one. That comes up to this center of this switch. And the other one's the bottom. You know, I can get at the bottom there. I can get at the bottom. Just take it right off. Make sure I got the right one here, yeah. Take it off here. That's 2. And this guy is looks like a small one here. 0.01. 0.01. Now we're going to stick a 0.01 in there. It's a long ways. The leads are long enough, but just barely. I think I'm going to do this one first up here because it's just a little easier. I want to fish the wire up. Do there. And use the entire wire pretty well. My videos I've been showing less and less of this kind of work, and I'm not including it in the video. The main reason for that is for my own sake in trying to get more work done. When the video is running like this, often I am slowed down substantially. I've come to realize it's much worse than I thought. I've been working with cameras running for so long I kind of forgot what it's like to work without them. I can go 2 or 3 times as fast, and you know, it's only so much soldering that people can watch. So that's why in my videos you'll see a little less of this kind of thing these days. I try to concentrate on more investigations of the radios I'm working on, you know, both the stuff you usually do when you're working on a radio, and some other curious things that I'm really quite interested in exploring. That's really what I want to focus on. Soldering parts in is not a thrill for me, personally. I've got this thing positioned over top of these wires. Doggone it. I kind of want it to go underneath. Whoops, that was a mistake. Over here. It's not a bad mistake. It's not even a mistake now. There we go. It's down where I want it. Is this long enough? Whew, just barely. I don't think this cover I cut is long enough. Yeah, maybe. I mentioned a TV show I really like to watch called Mayday. There's another show I'm really getting a kick out of, and that's The Curse of Oak Island. And if you're not watching that, maybe you should. It's quite an enjoyable show. Now, you know what, this is so short I'm going to have to lap solder this, which I don't really want to do. Maybe I can be lucky. Melt the solder, pop it in the hole there. Pop it in the hole that must exist in there. We will try that. So this is the kind of thing where the camera really is causing a problem, because it's exactly where I want to put my hands and stuff. This is not going to work like this. But I'm going to let you watch anyway. Okay, did I make any difference there? Change hands. Feeling if I manage to hook it in the hole, it's just going to pop up. There, that's better. Now I got a real hook on the end. There's one thing that frustrates me, and it's when things go the opposite way from what I want them to do. And the more I try to get them to go a way, they go the opposite way. I find that very frustrating, very quickly. And now, what am I going to do with 2 pliers? Now I'm going to tell you how to avoid getting injuries. Not that it has too much to do with this, but it just came to mind, and it's a nice piece of information. So let's say you're doing something heavy duty, like under your car. You're working on something, and you're trying to tighten a bolt up way up inside, you're laying on your back, you're heaving away, it's not working, it's not working, it's not working. You're setting yourself up for an injury. What's happening is the muscles are getting tired. Maybe you're holding a heavy tool up. You're tiring out. But you have the sensation you've almost got it. Tiring out, getting frustrated. You start shoving. You start shoving and pushing. That's the time to stop. Because you have tired, strained muscles. And you start shoving and pushing. And that's when you're going to get hurt. The way you solve it is you recognize when you're worn out. You do what I do right now. You just stop. You just let your arms come down. Just stop. About 15 seconds it takes. And what's happening is you're flushing stuff out of your muscles and that. You will feel it. I mean, you do this, right? We all do this. It's just if you do it with purpose, you will avoid a muscular injury. And it can be severe. That's on there. That's on there without any shorts. Good. That's another one done. Alright. Straining. Muscles tired. other muscles start to compensate for the tired muscles. And this is where the injury is going to come from. Because when you really heave-ho, you're at the last minute, I'm going to get that heave. You're heaving with a weird set of muscles now, and everything is tired and worn out, injured. You might not even know you're injured at the moment you did it. Probably will, but you may not. Next day you wake up, you're sore as heck. That's what it's from. If you just take the 15-minute break, let your muscles relax, and there's all kinds of situations in life where this pays off, not just when you're under your car. Wonderful. And I learned that from a young man. He was probably 20 years old, a university student that came into our company I was working in, and he was touring around with the safety department giving little talks, and he gave this talk to us, and he just told us this stuff. I never heard it before. And I think it's really served me well. So I'm happy to share it with you. Save your back from injury. Now who's next? Could be this guy. Yeah, let's do this guy, because he's not going to be down in this area anyway when he's done. And this one is, how big? It says tiger on it. I think that's a bad sign. Yeah, I can't see the size. Yeah, let's cut him out of here. Get him out. Tiger. I think that's a bad brand. You know, here in 2020, your capacitors didn't last 10 times their planned life. What a terrible thing. I can't see the value on it. So it's buried under this wax. Where would it be? It says, that says something other WA. That's Cornell WA, I think it's the name of the... Where am I going to scrape it? Right there. I see MFD there. Right in this dark area. You don't want to scrape so hard you scrape off the words. 0.025 is what's coming up. 0.025. I made a mess of my tool. Okay, not bothering to check on the schematic. 0.025. Have I got such a thing? 0.025. 025. I got a 0.02. Why would it matter that it's a 0.025? Why do they want the extra 5 in there? What is this thing doing that would require that? If I put a 0.02, surely that's good enough. It's not good enough. It's this one. It's not this one. It's this one. Yeah, no doubt about it. .025. How much difference can it really make? I don't know. Okay, let's see if we can. You know what? It's worth figuring this out, because figuring out what that capacitor is really doing. Because here's this terminal strip with the resistor to nowhere, and there's the terminal down here going nowhere. Something's missing in here, and the capacitor I'm concerned about is connected right here to this resistor. So I'm going to right in the zone. Might as well solve the whole package here at the same time. So the easy way is to track back on the schematic from here, find this resistor, and then find this terminal. Let's do that. Okay, volume control. There it is. And there is the little capacitor. That is what I think is missing. Point looks like 005. And then there's a 39K. Yeah, 39. Yep, that would be 39K. The little resistor is a 39K. And then off of this end here, oh, it's B minus, so there's a billion things coming off of it. So there's a capacitor, the one I'm working on, that goes to, I think it's going to ground. Capacitor to ground off the end of this resistor. Capacitor to ground off the end of this resistor. to, wait a minute, wait a minute, I even got back, yeah. To ground, this is the ground point right here. This is the B minus. So that didn't work out. Let me check it again, what I'm doing here. What am I doing? It's coming, I believe, this capacitor is missing. I have this resistor sitting open here. An open resistor in the audio circuit. It's connected here though. It's tied here. Off of there is another resistor. That's a brown, green, looks like brown, green, brown. Brown, green, ground, that'd be like 150 or something like that. 150. 150. Maybe 150 ohm resistors kicking right around here. Anywhere off this line. Yeah, 150 ohm. That's a 330K. What would a 150 ohm resistor be doing in here? Chances are I didn't read it right. All the way up to there, 1 meg. Ooh, anywhere off of here. Even off this wire. Nope. No whopper. Hey, look at that. 150K, 150 ohms, right there. That's the guy. So I found R16. And I come down here. There's a big 50 microfarad filter capacitor. And then back here is this one. This is 0.05. Didn't I pull out? Am I losing my mind? I pulled out a 0.025, didn't I? Where's that? Where's there? No, 0.025 is half this size. Smart, aren't I? 0.025. Do I even see one in here? And we have no parts list to go on. Okay, 0.025 connected off this line somewhere. Oh, there's that weird one there. I'm not sure what that's talking about. 0.05. That's pretty clear. 0.02. It's got to be a 0.025. They wouldn't put the 5-digit in place if it was a 0. It can't be 0.020. They just don't do that. So where? Oh, no. Oh, there it is. Really? 0.025 here? Is that what that is? Right across the power line. Right across the light bulb. Ooh, really? Okay, so we can trace these wires a bit. We should get to the plug pretty quick, or the switch. And the light may be in there. Okay, wow, that's a little surprising. Maybe there's another 0.025 and I just haven't found the whole story yet, but let's run with this one. Let's say it's that. Is it that? How can it be that? It's look at this. So one terminal. It's a little hard for you to see. I realize it's very hard to look at this kind of stuff in a camera in 2 dimensions. I get to see it in 3 dimensions because I have 2 cameras in my head. So lucky me. So I'll give you the poor guys 3D. So this is the one lead wire here. It's just cut free. This one here for the capacitor, and on it is a black wire, and that wire is off to the 120 volt light bulb. So the one side, yeah. Now the other side is up here. What? How does that become? So there's a wire. When I stand and look like this, in this angle, like the same angle you're now looking at it, it's hopeless to see that there's a wire underneath this terminal that casts back right to the switch. But it does. So I got down on my knees and looked. Well, not quite on my knees, but so that's it. So that capacitor is right across the power line. Right across the power line. So I got special capacitors for that duty. I'm going to grab one here. I bet maybe I got a .022. Hey, that'll do it. So these are special capacitors for this purpose. This is an X-type capacitor. Go right across the line. X across the line. So I'm going to put this guy in to replace the one I just took out. Somewhere in here. Good. There we go. Oh, I've got the ugly guy to do here. I wonder what his job has been. Why did he get so ugly? Okay, let's cut him out. Just notice a huge high wattage resistor back here. Looks like red, brown, red. Maybe 2100 ohms back there. Probably more likely part of the power supply. Since that rectifier tube is here and the output tube is just right next to it there. Let's get this crazy ugly capacitor out of here and get a look at it. Oh, just heard that come out of the speaker. That's pretty interesting. Charge is held in these capacitors all this time. Pull this guy right up here. There and there. Okay. 0.01. It's a very unusual looking capacitor. Like, it looks smaller than most. 0.02. Is that 0.02 or 0.01? 0.02, I think. 0.02. The wax is all bunged up on this, something terrible. 750 volt, that's an unusual number. Usually these are 600, so there's something unusual about this guy. Type 743. TCC, type 743. Some kind of special capacitor here? I don't know. I'm going to check into that a little bit. Okay, so I finished my research and there is something special about this capacitor. Let me show you what I found on the internet. Page 54 of a very long document. This is page 54. Let's shoot to the top. I'll show you what this is. Practical Radio for Beginners, book number 2. Bernard's Radio Manuals, number 139. What year this is, can we find out? Because this is old. So, 1955. First published in 55. Wow, I thought it was much older than that. This book contains some of the best descriptions of complex circuits that you find in radios that I've ever read. These long, detailed, well-written descriptions. I love this kind of stuff. But we're going to shoot to page 54. So this is really about how to build a radio. So a lot of this in this manual is instructions on how to build the radio. And then in it is sections that explain how the radio operates, and they are fantastic. We're going to get to page 54 here. Where are we? Page 42. Hold on, am I saying page numbers? It's a parts list. Wait, right here. Parts list of capacitors. Look, there's a type 346, but I'm looking for a type 746. This is TCC also. What does that mean? Temperature compensated? TCC? I gotta find that out. Come down here, we'll eventually find one that says 743. Type 743. TCC. Maybe there's another one here. It said something more. Maybe there's another one. This one. non-inductive TCC type 743. Oh, so I thought 743 meant non-inductive. There's another one, non-inductive TCC 346. Non-inductive. But here's TCC, they don't say that, non-inductive. So I haven't quite figured this out yet, but there's something special about that capacitor. I'll continue to do the research here. I thought I had it, but I don't. Non-inductive capacitor. Isn't that just kind of the way it is? So the most I figured out about this guy is that it's a temperature compensating capacitor, TCC. Although in some places on the internet they call TCC a brand name. I don't know if that's a mistake or not. Is it a type or a brand? It looks like a brand the way it's shown on here, TCC. So, and now where's this in the radio, and why would they put a temperature compensating capacitor into a cheapo radio like this? Where did they put this? So let me show you where this is in the circuit. It just gets a little more curious. So I had to hunt it down over here. That's it right there. The .02, which is essentially not, I was going to say across the windings here, but it's not. It's going from the plate of the output tube down to B minus. Or did I pick the wrong capacitor? Because it's on pin, one terminal is on pin 3 and the other terminal is on pin 8, but pin 8 doesn't appear here, so pin 8 is a spare. So what else is on pin 8? You know what else is on there? Bypass capacitor. Positive end of the bypass capacitor is there. What bypass? I didn't think there was a bypass in here. There's the 150. So I'm assuming something here. That the 100 microfarad capacitor is a bypass. And where is it going? I'm just looking at the radio here, just give me a second. So the negative is grounded. I believe that's a grounding terminal there. Oh, is it? It's a little too complicated just to gawk at. Okay, back to the radio here. Okay, so I'm trying to figure out what's going on with this guy. It comes to this terminal. Lots of wires leading from it. And that terminal is connected to the phono here, but this might actually be insulated from the chassis. Let's find out. Let's find out. So this is not ground here. And B minus, where's the B minus? B minus right here. So what's this capacitor doing in here? There certainly isn't any 100 microfarad called for anywhere. Pin 8 to this. Okay, so this is a pin on a tube. This is another pin 8. No, this is pin 1. This is pin 1 on the 12 SK7 IF amplifier. Pin 1 is the shell. This is tied back to the shell from the output tube, pin 8. Now what is pin 8 on a 35L6? Assuming they're the same, 50 and 35, 35, 35 L6. Pin 8 is the cathode. So this is the cathode terminal. That's where you would want to hook up the positive side of a bypass. And bypassing it to the wrong spot. That's probably what's happening there. He's probably bypassed it to the wrong spot. I'm going to take a guess. Whoever put this in here looked at this terminal and thought, oh, that's a ground point for sure. So just follow the wire. Oh, here's a good spot. I'll solder it there. And then this is running from cathode to B minus. But it's not. It's not called for. What was somebody thinking when they put that in there? What were they trying to get around? Or is there a bypass capacitor in there and I just haven't spotted it on the schematic because they've drawn it odd? Let's take a look again. So I'm talking about bypassing this. So the only way to bypass this would be to get onto pin 3. Oh, wait a minute. 3? What's going on there? I see 2 3s. Three. Okay, let me look in the book. 35L5. 35L5. Wonder if I have a 35L5 in my tube collection. 35L5. I might. Okay, 35L6. L6. What am I saying? 35L6. Pin 3 is the plate. And the cathode is 8. That's supposed to be an 8? Well, you know, chop a 3 in half, you do get an 8 out of it, don't you? You know what? That's grid number 3. That's grid 3, not pin 3. Well, it's not even a grid. What am I talking about? Well, it is, in fact. If you connect, yeah, this is really difficult to kind of perceive here the way they've drawn it too, but pictorially they're trying to show that there's plates up here, directing plates, and these are tied in fact back to the cathode. So pin 3, pin 8 reaches these plates too, so internally connected. It's just shown differently in my book because they don't bother showing this part as plates. They just show it as another grid here. So okay, so what's all this mean then? This means that capacitor, the positive end makes some sense, the negative end makes no sense unless the guy was really trying to attach it to a negative. Now in the manual there is no, I mean, it would have to appear here, connected here, the capacitor. There's no bypass. Why would somebody add it in? Hang on, wait a minute. There's a 50L6 here and somebody stuck this bypass in. They're probably the same person. So if you had low output from a radio, one possibility is the cathode resistor is eating all the signal because it's not bypassed. So you're sharing the output of the tube between the transformer here and this resistor. You can stop sharing if you put a capacitor in here and bypass this. Then everything the tube is doing gets onto this guy. He gets the whole thing. So this radio as it stands now, you could argue that the output will be restricted by the fact that they didn't bypass this. You could unrestrict the output by putting in a bypass capacitor. Would that affect the operation of the tube any otherwise? I don't think so. Now you come along and pop in a 50 in here. Why would you do that? You only had a 50. I only had a 50. You had to put in, hey, it worked. It's kind of quiet though. Why don't we bypass the resistor? Maybe that'll give enough. If I bypass the resistor and stick a 50 in here, maybe we'll get enough to drive the speaker. Maybe that's what happened. Maybe that's how that got there. I really have to put a 35 back in here. So I think maybe I'm going to look into this a little bit further and see if I have a 35L6. But bypassing this with a 100 microfarad capacitor, well, that's more than necessary, I'm sure, but harmless in itself. It's harmless to put in a bypass here, I think. all it would do is just increase the output a little bit. 35 L6. Got to go rummaging. I have all the L6s in one container, I think. Let's see what we can find in here. This is my box of L6 tubes. Bearing in mind that the Granddaddy 6L6 is actually electrically quite different from all these other ones here. So now what I'm going to do, go through them all. That's a 50. And look at them. I got them all numbered, and they're all cataloged, and their test results are also cataloged. That's a 50. That's a 50. Let's go to the other end. 50. Oh, those all so these are all good tubes too. These are all 25. Looking for 35. Show me a 35. 50. I have a lot of 50s. 12. 12 L6. 12 L6. 12 L6. I should just call up my record. 50 L6. I got a ton of them. 25 L6. That's close. We're looking for a 35 L6. 25. 25. 35 L6. There's one right there. How much do I bet? This is one too. 35 L6. 1, 2. 50. 50. 50. Well, no shortage of 50s. Two 35 L6s. Tube number 7 and 8. I will look at my record and we'll see how those two tested. Here's the L6s here. Look for here we are, 35. Here they are, 7 and 8, tube 7 and 8. So tube 7 tested very poorly. 250 and it should be coming out at 990. Tube 8 did okay at 850. I only have one. You know what I'm going to do? I'm not going to change the tube. The radio's working with a 50 in it. I'm going to leave it that way. 10.3. I got a whole bunch of good 50s, but I only have one good 35. Interesting. Yeah, you know what? I think I'm going to leave it to come to think of it now. You know, I know I have them, and I know one of them's good. So I know if at some point, if there's something about the radio that suddenly I decide it must have the proper tube in it, I will do that. So for now, the radio is probably suffering from slightly reduced filament current, probably causing all the tubes to run cooler than intended. Output tube too, I think. I can actually measure some of those heater voltages and find out what's really happened. Oh, you know, the more I think about it, the more I think, wow, that could really be a disturbance in the radio. So I think what I'll do is I'm going to remove this capacitor, having concluded it's not really, it's not really from here. It's a foreigner. He's not from around here. Out you come. So with that, we have done all the audio capacitors. Maybe one or two of these might be part of it, but really the audio part's been done. Wait a minute, no it hasn't. What about this guy? What about that guy? It's coming from a pin on the IF tube. Shake out the little tidbits I've dropped in there. Okay, let's find out about this guy then. So it's pin number 1, 2, 3, pin 3 on the SQ. Capacitor on pin 3 of the SQ. Okay. Pin 3 of the SQ. Pin 3. 3. Oh, you know what that is? That's a, is that a grounded pin? Pin 3. It's got a lot of stuff hooked up to it. It's definitely pin 3. Pin 3 is a busy, oh look at it. Yeah! Wow, all this stuff. So in amongst it is going to be a capacitor going over, going back to this tube. Who would even look like that going back to this tube? So it'll be a little more specific. Coming off of the SQ tube, off of pin 3 for sure. 3, no, I don't think so. Pin 3. So what size is this capacitor? I'm taking a look now. 0.05. So 0.05, and it's going over to pin number 3. So it's going to pin 3 over here. So here's pin 3. Or is that pin 8? Look at that. That's pin 8. This is pin 3. Pin 3. I don't see it. I said 0.02, didn't I? 0.05. Oh, this must be it here. ABC capacitor. What I believe is the ABC capacitor. So that would go on to, oh yeah, attach on here, and this is 3 over here. So we got 3 to 3. That's it. Well, that's a pretty important capacitor. Yeah, I think we're going to do that one. It really isn't so much an audio capacitor, but let's do it anyway. It's the AVC capacitor. Okay, back to that. Wait, we're going to do it sooner or later. I think I'm going to do it sooner. So we'll do this one, then we're going to test the radio, and then I'm going to call it a day here. Okay, let's solder this guy in here. Yeah, when I find things that don't add up in these radios, I get a little paralyzed by it. I guess anybody would. Start doubting yourself, which is a good idea. Self-doubt can be useful at times. Not all the time. Reason for testing the radio at this point is to see if it still works. I didn't solder that at all. Looks like I didn't solder it. It's just I'm just being fooled by my eyes. I think that piece fell in. Yeah, it's right there. No shorts possible. What did I didn't decide to do anything with this. I didn't decide this. So I don't have a lot of options. I mean, I just got 0.02s. So I'm going to stick a 0.02 in place of it, regardless of what magic might be in that capacitor. Oh. I'm going to take a wild guess that, for various reasons, these radios drift a bit as they warm up. And there could be 7 different things causing them to drift this way, that way, every way. You can compensate for all of them if you just put a counteracting drift back at them, whatever it is. So, where'd that capacitor come from? Oh, it was right across here, wasn't it? It was right in here. It's right in here. It's a tight fit. Okay, I'll put this one right in there too. Solder them up there. Okay, it's time for a test. Again, not that I'm expecting the radio to be super duper functional. I haven't done anything to the radio side of it. And the audio side seemed okay. This is just a test to make sure it's still operating. Before I get too far into it. You know, if you're doing this and you make one mistake, you can probably sort it out. If you've made two mistakes, the whole thing becomes a lot more complicated. And as everybody knows, finding your own mistakes is tricky. I think we're set. Okay. Switch is on. Okay, here comes the power. Now again, this is the big test here. I boot things up, stuck a short in there, anything at all, could have gone wrong. This light's going to come on and yell at us. The light is quiet. I saw a little orange glow in it. All is good. You can see this tube filaments are heating up. All is good. Might be very quiet. It's got 0 antenna on it. Oh, is it set to phono? Or I think it's set to phono. No, we're on radio right now. Wait a minute. Yes, definitely radio. I'm going to give it an antenna or something very similar to an antenna. We'll go on the chassis and right onto the volume very low. Bypass gone. Bypass capacitor gone. Volume, it's full, very low. You should stick a 35 in there and see what happens. We're not picking up any has a definite grindy sound to it. I think it's the spring actually making that sound. Well, it picks up something, has some kind of tuning going on, something getting through it. Good for now. That's good for now. We don't need any better performance out of it. So next on the hit parade will be oh, you know what? Let's put the audio through. Yeah, I'm all set to do it. Let's do it. Let's do it. So it sets off at the moment. Put this back in here. I mean, it sounded fine before, but let's just make sure. Flip it over to phono. Power it back up. I still have my signal generator running up here. That sounds like a ground is off. That's all that nonsense. Bad wires? Funny things happening here. Oh, funny things happening. Sounds like feedback, doesn't it? Come on out of there. Get out. Okay, I don't know what's going on at the end of this wire, but I should not have done that test. We're going to go on the assumption that everything's fine for now. Anyway, and I'm going to continue on doing the radio capacitors at the front end. And at that point, this guy should actually sound like a radio. That's my hope anyway. So thanks so much for watching this video. And lots more things to do with this radio yet.